Hello everyone and welcome. My name is Jason Gregerson. In this video we're going to talk about linearly independent sets of vectors versus linearly dependent sets of vectors. In general for this topic we're going to talk about the definition of each of these and how to determine if a set of vectors is one or the other. In another video we'll talk about the shortcuts for determining whether a set is independent or dependent. And in a third video we'll talk about the implications of what it means to be independent or dependent. But in this video we're going to focus on the definitions and basic use. So definition, a set of vectors is linearly independent if the homogeneous vector equation has only the trivial solution. Okay, so we got our homogeneous vector equation here. What is a solution to the vector equation? Well, it's a set of values for x1, x2, and xp that satisfy the equation. Now the trivial solution means if all those values were 0. Because this is a homogeneous equation, in other words, that right-hand side is 0, we know that if we took 0 v1 plus 0 v2 plus ... 0 vp, we would get 0. So we know that having the weights of 0 is a solution. We know that the trivial solution is a solution. The question here is, are there other solutions? If the only solution is the trivial solution, then that set of vectors is linearly independent. And then for linearly dependent, it's if we have other solutions than the trivial solutions. Okay, so I know once again that if I use all zeros, that is a solution. But if there's another set of solutions, maybe there's 0x1, but there's 1 of v2 and negative 2 of vp. If that satisfies the equation, right, if there's another solution other than the trivial solution, then that set of vectors would be linearly dependent. So now we've defined independence and dependence based on the number of solutions to the homogeneous vector equation. But we also know that for every vector equation, there's an associated matrix equation. So if we let the matrix A have columns that are those vectors v1, v2, ... vp, in other words, we build a matrix whose columns are the vectors, then we could define independence and dependence in terms of the matrix equation. We would say that then the vectors are linearly independent if the homogeneous matrix equation has only the trivial solution. So it really doesn't matter if we define this in terms of the vector equation or the matrix, associated matrix equation. Now this definition basically tells us how to figure out if they're independent or dependent. What we have to do is figure out how many solutions there are to the homogeneous equation. So let's actually go through that process now. Is a set of vectors independent or dependent? Okay, so what we have to do is solve the homogeneous vector equation. So first I'm going to write out that equation. And I actually don't have to go through the full solution process because really what I'm trying to do is figure out how many solutions. If there is only one solution, the trivial solution, this would imply that the set is linearly independent. If there are infinitely many solutions, this would imply that the set is linearly dependent. So how do I solve this vector equation? Well, I would set up the augmented matrix. So I'd write the augmented matrix and do my row reduction. So in this case, my first row operation would be to take row 3 and replace it with row 3 minus row 1. In that case, my first row would stay the same, my second row would stay the same, and my new third row would become 0, negative 2, and negative 2, and then 0. That's doing my first row operation. My next row operation, I have my first pivot here. I can identify my second pivot here. I need to get zeros below it, so I got to get rid of that negative 2. So I'm going to take row 3 is equal to row 3 plus 2 times row 2. And now I'm going to go through that row operation. First row stays the same. Second row stays the same. My new third row becomes 0, 0, 0, 0. Now at this point, I'm in REF form. That means I can identify exactly where my pivots are, and I can determine how many solutions there are. So to answer this question, I just need to know how many solutions, not specifically what they are. So in this case, I can see that I don't have a pivot in this third column, so that means that x3 is a free variable. And because it's a homogeneous equation, I can see there's not going to be a pivot in that far right column. So there are going to be solutions. And because I have a free variable, I know that there are infinitely many solutions. And then that tells me that the vectors are linearly dependent. So we can see that to figure this out, what I'm going to do is I'm going to set up to solve the homogeneous vector equation. I'm going to form my augmented matrix. I'm going to row reduce to REF form. And then, if there's only one solution, the vectors are linearly independent. If there's more than one solutions, the vectors are linearly dependent. All right, that concludes this video. Thanks for your time.